we said that we need to determine the length of AB in order to calculate delta L of AB, okay? So delta L of AB is the length of AB at this position. And as you can see, if you look at the figure, you have, this is the perpendicular line. This is a perpendicular line. You have, this is 3 meters, and this is 4 meters. So if you apply Pythagorean theorem, what will be L of AB? It will be equal to radical 3 square plus 4 square, which is 5. So delta L of AB is 5 minus 3 equals to 2 meters. Okay? And you have that KAB is 30. So now you can say that tension in AB is equal to 30 times 2 equals to 60 Newton. Okay? Clear for the one who asked for this about the magnitude of TAB?
Yes, clear. Pythagorean.
Pythagorean, yes. مين كان عم يسأل؟ Yes.
دكتور كيف عرفنا أنه it should be LB يعني L of AB?
Okay. What is the definition? Look, this distance between A and B will vary because of what? Because of the spring.
Yes.
And the variation in AB, okay, is due to the variation in length of the spring. They told you that when the spring is unstretched, what was the value of AB? 3 meters. So when the spring will stretch, any stretching of the spring will add to the length of AB. So the stretching of the spring is simply the variation in length of AB. It's the length of AB at any position minus the unstretched length, which is 3 meters.
Okay, thank you.
Okay. For the person who was asking first, you want me to continue? This was your only problem or only the remaining part?
The remaining part ما عرفت إنه هون بدي أعمل analytical و geometrical.
Okay. So let us continue. Then I know now the tension in AB 60 Newton. Okay? Okay. So let me annotate now my figure again. This is the weight, mg. I will take G to be 10 for simplification. So I have 10 m here. I have the tension here equal to 60 Newton. Since I have all dimensions in my figure, I can calculate this angle theta. I will call this angle theta. How to calculate theta? Tan theta is 4 over, so it's this distance, which is 4, over the height, which is 3. So tan theta is 4 over 3. So I can get the angle theta, okay? I am done with this tension. I move to the other. For the other side, I don't know TAC, and the question is to find it. So I will put the unknown. I will say this is TAC to be calculated. And I will say that I have an angle here to be determined. I need it for my projections. I will call it beta. Also, beta can be easily calculated because you have, this is 3 meters, and this is 3. So you can directly say that beta is 45 degrees. Okay. Now that I did my annotation, I got my angles, I have only 2 unknowns, the mass and the tension. So all I need is to write 2 equations. If I use the analytical method, can you tell me what will be these equations in analytical method?
TAC plus TAB plus the weight equals 0.
Okay, how deca vectors? You need to project on X and Y. Okay, so as you said, the main equation is TAC vector plus TAB vector plus the weight equal to 0. Okay. Now I will project. If I project on X, what do I get? What is TACX? It's so now in X. Okay. I will project in X, sum of X equal to 0. According to the figure, TAC projection on X is negative. So minus TAC, هلا beta is 45. So you can do cosine or sine, it doesn't matter. But if you take beta here as an angle, so if we talk about any angle here, you should do on X sine. So minus TAC sine beta. And I replace beta by 45. Plus TAB sine theta. And I know TAB, I know theta, I replace them. Okay. Equals to 0. My only unknown in this equation is TAC. Because I calculated already angles theta, beta, and TAB. So from this equation, I get my first unknown, which is TAC. Once I am done with this equation, I can move to sum of y equals 0. In sum of y, I have plus TAC cosine beta plus TAC plus TAB, sorry, cosine theta. And I have now everything. All these parameters, I know them, I replace. So plus TAB cosine theta minus mg equals to 0. So minus 10m equals to 0. What is your only unknown in this equation? The mass is your only unknown. You have already calculated all other parameters. Okay. You replace a TAC that you got from equation 1 in equation 2, you get m. This is the analytical method. So when they say analytical method, you project on the axis, x and y. Clear about the first method? Any
Yes,
question
thank you.
about the first method? Okay, let us move to the geometrical method. The geometrical method will start from a vectorial relation. What is the vectorial relation we discussed? TAB plus TAC plus W vector equal to 0. Okay. You are familiar with the geometrical method in case of resultant, but it's really the same thing. Okay. If you take the weight to the other side, what can you say? If I take W to the other side of the equation, I can say that TAB vector plus TAC vector is minus W. So all I have to do is to draw the triangle of vectors. And then I will have a triangle in which I will apply sine and cosine law. So TAB plus TAC should be the resultant of this is minus the weight. Okay. So let me represent this in a triangle. I can start from any point. I'll take any point here. Okay. I start by drawing the first vector. The first vector, I know that the resultant is minus W, and since the weight is vertical but downward, minus W is vertical upward. So this is minus W up. So I have a vector up equal in magnitude to m times G. Okay. Now, from the first point, I can draw or a parallel to TAB or a parallel to TAC. You can start but what you want. If you want to start with TAB, you look at this figure. What is the angle between the vertical and TAB? We called the angle theta, and we calculated theta. So you take the point here, you draw a line doing an angle theta that is already calculated. I know theta. And I will say that this is T of AB. Now, from the extreme point, I draw a line parallel to AC. And this line is doing with the vertical also, according to my calculation, an angle of 45 degrees, which is better. So I draw a line parallel to AC, and I say I know that this angle is 45 degrees. Okay. So now I will draw again the triangle to be clearer. I have a vertical. And for this vertical, I have mg as magnitude. I have vector AB from this side. And I have vector TAC from this side. And this is 45. This is theta. The angles, all angles are calculated already. I know theta. I know beta. Okay. This is TAB. And I also know TAB. TAB is equal to 60. So I just annotate my figure. I have TAB. My unknowns are only the mass and TAC. So I just have to apply sine law here. Okay, because I know all of my angles. Since I know theta, theta is calculated from the first step here. This is theta, okay? And this angle 45 is also known. So I can calculate this angle. This angle is 180 minus theta minus 45. Since I know all angles and I have only one magnitude known, and I need to get the two other magnitudes, I apply sine law. From sine law, I can write the following. mg, and g is 10, we said. So m times 10 over, I will call this angle 180 minus theta minus 45. I will call it alpha. So over sine alpha, and alpha, I know it, I replace it, okay? Equals to TAC over sine theta and equal to 60 over sine 45. Okay. So now all you have to do is first to apply between these two terms. So if you take these two terms, theta is known, TAC is unknown, you get TAC. Okay, then if you take this term with equal to 60 over sine 45, you will get m. And these are your two unknowns, m and TAC. You are done. Okay. Question on this?
Professor,
Yes.
can we do at the same test but problem 1? I didn't quite get it yet.
Yes, sure.
Problem 1 equivalent عنا أي شيء؟
Problem 1 خليني نشوفه 1 minute.
الضوء بس ما
دكتور،
عرفنا فيه.
بس هيدا الاكسرسايز سؤال صغير.
You don't have this, guys. You don't have this. Okay?
Okay.
You don't have this problem for the exam. Whenever you see distributed load or whenever they tell you replace by a single force, you don't have all of these. Okay?
دكتور
Yes?
بتشابتر 3 في تو بروبلمز صعبين شوية، ما بعرف إذا عنا إياهم.
لا رح اقول لكم البروبلمز اللي ما عندكم اياهم. يلا بال2 everything. Okay? In chapter 3 في two problems that are complex, very complex in geometry, don't do them. يلي هن this one 68, do not do 368. هلا هي if you want the method is not complex but the geometry is complex, so don't worry about this. Will not give you such complex things. 68 no, and also 69 no. So skip problems 368 and 369. These are the
Can we
problems
do,
you are talking about?
Yes. There's one more 344 إذا فينا نعمله please.
Yeah, 344. Yes, okay. Let us. What was your problem in this case, in this exercise?
Nothing. It's يعني ما كتير فهمت the question و the figure شوية هيك
Okay.
I don't know.
Yeah, let us do it together again. A scale is constructed using the 10 kilogram block and the pulley and cord arrangement. Cord BCA is 2 meters long. If S is equal to 0.75 meters, determine the mass D in the pan. Neglect the size of the. Okay. So first, let us do a small analysis of the problem. This system was used previously to measure weights, okay? And the idea is the following. No, depending, there is a relation between the length S and the weight. And this is what we will try to find in this problem. To be able to connect these two things, let us think first about what is the point in the figure that is joining all forces. Look at your figure. You have one point of intersection of all forces. What is this
Here.
point?
Point B.
Point B. So if you take point B, B is in equilibrium. What are the forces acting on B? You have first the total weight here, which is due to the weight of D plus the weight of P. Okay? The weight of P, you know it. So once you have the total weight, you can deduce the weight of D. Okay? So I will call, this is my first unknown, which is M total times G. I need to get M total. Okay? Now, next, what do we have also at B? We have two cables. We have, if we call this point D, let's say, you have, this is TBD. Okay? And you have the tension in this cable, this one. I will call it TBC. I will call it TBC. Okay? Let us consider now this cable. Look, this cable is turning over this pulley and is attached to the weight. And we know that in the same cable, we have the same tension because we have massless, frictionless pulleys. Okay? So in this cable, the tension is the same everywhere. And are you able to get the tension at A? How to get the tension at A?
We project on Y.
Yes, you consider the block. If you consider the block, what are the forces acting on the block? You have the weight of the block, and you know that the mass here is 10 kilogram. Okay, so they used G to be 9.81. So the weight here is 98.1 Newton. Okay, and what will make the system in equilibrium is that you have the tension in AC. So TAC will oppose the weight of the block in the vertical direction. So if you do sum of Y equals to 0 on your block, you get that TAC is equal to 98.1 Newton. Okay, so you have now this unknown, this tension, you know it. Okay, so you can replace it directly in your figure by its value. So you still have two unknowns to solve for. You still have two unknowns to solve for, which are the value of TAB. Okay, you need to determine what is TAB, and also you need to determine what is the mass. You have two unknowns to calculate, okay? And to calculate two unknowns, you just need two equations, okay? Now, here also you have two methods to apply, analytical and geometrical. So as usual, same approach. Or you select analytical method or you select geometrical method. Okay. Now, to be able to do any of these two, analytical or geometrical, you need to get your angles. You need to know what is theta and what is phi to be able to project your forces on the axis x and y. So next step will be to try to determine your angles. We'll try to find the angles. Okay. So to find the angles, we need to do a small analysis for the geometry of the figure. Let us look at our figure to see how to calculate the unknown angles. Okay. What do we know about this figure? We know that in this triangle, this is 1.5 meter. This is 1.5 meter. Okay. And for BC, we know about BC the following. The BC is a part of chord ACB. And you know that the total length of a chord is a constant. So you can say that the total length of the chord is equal to AC plus CB. Okay? Now, they told you that the total length of the chord is equal to 2. L is 2. And also they told you that at this position of equilibrium, S is given to be 0.75. So you know that AC is 0.75. Then you can deduce from this equation that CB is equal at this position to 1.25. So this is equal to 1.25. Okay, so we can annotate this here. Okay, once we know all of these dimensions in one triangle, we can calculate the angles because you can use first the
دكتور
cosine law. Yes.
دكتور سؤال هلا هون نحن فينا نعملها كوساين بس
إيه.
انا كنت عم جرب حلها بطريقه بس ما زبطت معي. نحن الاس اذا بنعرفها هون 0.75
إيه.
وهيدا 1.25 ما في
منن
لقي
A و B
الانجل.
A و B guys A و B منن same level. هي الفيجر بتغش. الفيجر بيبينوا A و B at same level. It's not the
اوكي لان
case.
كان بيطلع غير رقم معي.
إيه. It's not the case. هيدا منه right triangle. So please don't rely on the figure as you see it. You might have misleading figure. Okay. حدا قالكم انتو انه هيدا انه هولي على نفس الليفل B و A؟ نو ما حدا قال. اصلا هن حطوا هون اس، ما حددوا اذا هيدي الفيجر هي for S 0.75. So A and B for S equal 0.75. اصلا ملايكو مش هيدي 1.25 بالكيس تبعنا. اتس كلير انه هيدي الفيجر منا بالبوزيشن اللي نحن بدنا اياها، لانه هيدي الديستنس كلها سوا 1.5. سو اكيد هيدي ما حتكون 1.25. يعني الفيجر منا معموله مزبوط على سكيل تو ذا بوزيشن اوف equilibrium shown. فما فيني اعتبر انه A و B are at the same level. If I do this assumption, of course I will get wrong results. انا بدي اعتمد بس على الانفورميشن يلي معي اياها. They didn't tell me A and B are on same level, so they might be at different levels. يعني هن حاطين حيلا position بس actually S is different. يعني بدي أعمل calculation تعرف وين A على مزبوط. Okay, so that's why I will not consider إنه هيدا on same level وهيدا right triangle. This is a wrong assumption. So now, once I say I have these three lengths, I can find all the angles that I need. Okay, in this triangle, I can calculate using the cosine law first this angle theta. Yani I write 1.25 square is equal to 1.5 square plus 1.5 square minus 2 times 1.5 times 1.5 cosine theta. I get theta. Once I get theta, I can move to sine law now. Okay, I can move to sine law to get, for example, beta here. هلا هن سموه فاي، هيدا سموه فاي. اوكي، او بالعكس خليني احطهم مزبوط، لانه look how they define the angles. This is TBC. They define the angle between TBC and X to be theta. According to my figure, this angle is equal to this one. يعني أنا when I find theta in the triangle, this will be equal to this angle. Okay? And when I find alpha in this triangle, this is alternating with this angle. So once you find these two angles using cosine and sine, you will be they called it phi. خلينا استعمل نفس same names. So this is phi. Okay. Once you use cosine law then sine law in your triangle, you will be able to get phi and theta. And once you have phi and theta, you are free. Here they didn't mention a method. You can use analytical, you can use geometrical. It's exactly the same procedure we did in the previous. You have two methods, or you project on X and Y, or you draw the triangle of forces with the angles, and then you solve using sine law and cosine. Okay.
دكتور بس عندي سؤال.
Yes.
هون بالتراينجل ما فينا ناخده انه ايزوسيل لانه
فينا ناخده ايزوسيل اكيد فينا ناخده ايزوسيل يعني هول التو انجلز ايكوال. يس this is theta.
يعني اذا الانجل اللي
بس
فوق بالكوساين لو هوليك يعني اللي بيبقى يعني
exactly
180 هيك مش هيك؟
مظبوط كمان. of course you can. Of course it's enough to get لأنه it's isosceles triangle, it's enough to get phi from cosine law and say because these two are equal, no need to use sine law. We can directly say that theta is 180 minus phi over 2. Of course it's also possible.
Yes.
This is easier. Okay, but it's a particular case.
Thanks.
In case you don't have the same lengths, you need to do sine law. Okay. Other question?
دكتور
Yes.
spring 24 number 2
Yes.
مكتوب بالquestion projection vector
يلا one
بس
second.
ما رجعت عملت مرتين times unit vector of BC مثلا يمكن
بالغلط بيكون ناسيين السوليوشن بالغلط مش مشكلة.
يعني عملتها على
بس
اساس
إذا
projection
projection
component.
vector, yes, you multiply by the projection vector, by the unit vector of the line you are projecting on. Okay. So when طلبوها, let me check.
بالسي
Part C determines the projection vector of F1. Yes, أكيد. You need on the line of action of 800 LB. يعني من بعد ما يطلع لنا projection component, we multiply by the unit vector of FU. Okay, أكيد. Other question?
no.
دكتور أنا عندي سؤال بالبريفيوس اللي قبل هيدي
Yeah.
22.
Yeah, let me open it 1 second. So previous, you mean fall 22 أو spring 22?
الفول 22 صح.
fall 22. يلا 1 second. Okay, tell me which problem.
Exercise 2 part B.
Exercise 2. Okay. لحظة. It didn't open 1 second.
راحت السكرين ما بعرف إذا بس عندي.
راحت السكرين؟ كلكم راحت عندكم السكرين؟
راحت عندي.
Yes.
I will share again 1 second. Okay, do you see it now? Do you see the screen now?
Yes.
Okay. Yes, tell me.
Problem 2 part
Yes.
B.
Problem 2, part B. Yes. Find the moment vector this force exert about axis AG. Yes.
هلا بالسولوشن
نعم.
المفروض ان احنا نعمل اول يعني المفروض ان احنا نجيب فيكتوريال برودكت، بعدين اعمل انا انه برودوي سكالاري يعني مع
بس
الاي
في
جي.
أهين تريبل سكيلر برودكت. فيك تستعمل التريبل سكيلر برودكت، يعني تعمل
اوكي
الماتريكس بأول row you don't use IJK, you use unit vector of AGX, unit vector of AGY, unit vector of AGZ.
اوكي، بس في
اوكي
شغله تحت بدي اشوفها بالسولوشن يعني.
بالسوليوشن. اوكي
ايه هون
اوكي
آه
يس
عندنا
اه
720 تايمز 4 على راديكال اوف 20. هيدي صارت 480 مع الراديكال 20 اللي تحت هونيك.
غلط الكالكولاتريس.
وين قصدك؟ أي لاين you mean? which line؟
اخر لاين قبل السي.
آخر لاين قبل السي. اوكي this one. اوكي
ايه الكونستنت يلي برا اذا بنعمل لهم كالكوليشن ما بيطلعوا 480.
الكونستانت يلي برا. طيب خليني let me check one second. عنا أول شيء dot product هون ناخد I component times I component، يعني 720 times 4 over radical 20 I dot J 0. اوكي يعني هيدي هي أول term.
اوكي
Any term هلا we need to multiply, we need just to multiply by this. انت عندك radical 20 times radical 20 is 20.
20.
اوكي وعندك 4 over 20 يعني بيصير over 5. اوكي يعني 720 over 5.
اكيد بدنا 480.
اوكي بيكون yes it might be so it's wrong. يعني هون بس بدنا نحط 720 over 5. yes right.
دكتور
yes
انا ما كتير فهمت هيدي الايكويجن، هيدي هون لازم تنحفظ او
هيدا لا مش ضروري. ليك هن بهيدا الاكزرسيس لانه هين الاكسبانشن ما عملوها تريبل سكيلر برودكت. يعني هي شو الفكره؟ نحن اذا بدنا نعملها سوا اوكي لانه اتس ايزي تو يوز هيدا الفيكتوريال برودكت. ليش هين؟ لانه هن اخذوا فيكتور بوزيشن كتير هين، فقالوا لشو نتعذب ونعمل تريبل سكيلر ماتريكس، خلينا نعمل الفورمولا. شو هي الفورمولا؟ انت you want to project the moment اوكي of TCB. يعني اول شيء تنرجع للquestion، بدك المومنت about which axis؟ you want moment of tension CD. so you have this. one second just to select okay look this is TCD, this is your vector, and you want to find the moment of TCD about axis AG. Okay, so the method is that you can first take any point on AG. Okay, so sorry this is AG here لأنه أصلا إذا بيكون ال AB ما بيكون في moment صح؟ إذا بيكون هيدا اللاين ما بيكون في moment لأنه it's intersecting. They need the moment about this line AG. Okay, now what is the technique? We select first any point on AG. يعني you can take A or you can take G. هلا here G is easier. هلا we'll see why. Okay, if you take point G you need to get the moment first of TCD about G. Okay, now what is the easiest position vector to take? We said that the position vector should start from the point we want to do moment about to any point of the force. And as you can see, you can take or C or D. But C is easier. Why C is easier? Because GC vector is parallel to y-axis. So if you select R in a simple way, this will simplify your equation. Okay, so this is why I selected the easiest position vector, which is G, C. GC vector will have only one component along Y. So I can say now that it's easy to get the moment of TCD about G. All I have to do is that this vector is equal to GC vector, and GC vector is just 2J. So 2J vectorial TCD. Okay, you can do the matrix here, but because it's only here one component, they said no need to do the matrix. Let me do the expansion. Okay, so I expand first 2G vectorial TCD. I get the moment vector. Once I get the moment vector to project on axis AG, I do dot UAG, and then I will get a component. But because I need the to find, okay, if I want the moment vector, I should after I do dot UAG and I get the component, I should multiply again by unit vector of AG. If you don't want to do this, no problem. You can use the triple scalar method that we learned in class. So what you do then, instead of expanding in parts, yani first I get the moment, then I do dot UAG, I get the component, then I do times UAG, I get the vector. You can say, to get the component of projection, let me use the triple scalar product. Then what will be the first row? I want to do moment about AG. So I need, the first row will be unit vector of AG and X, unit vector of AG and Y, unit vector of AG and Z. This is my first row. My second row will be for the position vector. We selected the easiest position vector, which is GC. And we said that this corresponds to 0,
دكتور
2, 0, 2, 0. Yes?
سوري عم بقطشك بس هيدي بس البوزيشن فاكتور لازم ناخدها يعني 1 بوينت يعني عم نلقط بين الفاكتورز مش هيك
1 point على الاكسس يلي I want to do moment about.
1 بوينت على الفورس
1 point على الفورس. بنقي اهين فيكتور.
اوكي ديل
Okay.
ديل
The last
ميرسي
row is the component of the force TCD. يعني هون TCDX, TCDY. Okay. This will replace what? إذا بتعملوا triple scalar product, this will replace 2J vectorial TCD dot UAG. بتكونوا لقيتوا الكومبوننت، بس تتلاقوا الفيكتور شو لازم تعملوا آخر شيء؟ After you get يعني this is equivalent if you want triple scalar product هيعطيكم this term. It will